All right, today we are moving on to the characteristics of polynomial functions. This is continuation from before. Okay, so we are going to use the characteristics of polynomial functions to graph the following function. So the function we're given is negative x to the power 4 plus 5x cubed minus x squared minus 21x plus 18. Okay, so to find the roots, that means the x-intercepts are the zeros. We don't know these yet. So let's work through this. We're going to use factor theorem. The factors of 18 can be plus or minus 1, plus or minus 2, plus or minus 3, 6, 9, or 18. Okay, and when I go through and try some, I find that 1 is a factor of the polynomial. So we're going to divide everything by 1, by the factor 1. So we get negative 1, 5, negative 1, negative 21, and 18. Okay, so it worked out. So we know that 1 is a root, so we can add that right away. So we'll have 1 at 1, 0. Okay, so we're left with negative x squared plus 4, cubed, negative x cubed plus 4x squared plus 3x minus 18. And I try some more numbers, and I've come to realize that 3 is also a factor of this. So let's divide by 3. Okay, so now I've realized that 3 is a factor, so we can add that to our list of factors. And we're left with negative x squared plus x plus 6. I'm going to take that negative sign out of it and change all the signs of the equation. It's the factors of 6 that subtract to 1. It's going to give us x minus 3, x plus 2. So factors here of 3 and negative 2. So we already had a factor of 3, so let's put a squared there, and then we have another root of negative 2. Okay, so those are our roots. The y-intercept, so remember the y-intercept always comes from the value without a variable. Okay, so in our equation of negative x to the power 4 plus 5x3 minus x squared minus 21x plus 18, the c value, or sorry, not the c value, but the ending value, the constant value, is the y-intercept. So the y-intercept here is 0, 18. Okay, and then our knowledge from the first characteristics note for n behaviors. So we have a degree of 4, and it's a negative leading coefficient. So the degree of 4 means that the arrows will be going the same way, and the negative leading coefficient means that they will be going to the negative. Okay, so as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. Okay, and then when we're graphing, we're not going to know the turning points or anything, that's calculus, but we do know, we can put in the information that we know here. Okay, so when we're graphing, we will have x-intercepts at 1, at 3, and at -2. And you know what? For the sake of the graph, I'm going to make it so every 2 lines is 1. And on my y values, I'm going to go up by 2s because we have to get all the way up to 18. Okay, good. So now we can start graphing. So we have an x-intercept at -2, +1, and +3. Okay, and we know to the left of -2, it's going to be negative. And to the right of +3, it's also going to be negative. So we can just do that. We don't know the exact points. We just know towards -infinity, it goes down. And towards +infinity on the x's, it also goes down. And then the last piece of information we need to plot is the y-intercept at 18. Okay. So we can extend this line from -2 all the way up to our y-intercept because there aren't any x-intercepts in between -2 and 0. It will go straight down through our root at 1. And now this is the new part. Because the root of 3 is squared, right? It happens twice. It doesn't go through. It just comes down and it makes a parabola there. So it touches +3 and turns back quickly. Okay? And that's an acceptable graph for this equation. It's probably not the complete correct graph. Again, that's a calculus problem. Okay, so multiplicity. This is what we just looked at with the root of 3. And multiplicity represents order. So what that means is the number of times each factor occurs. So for example, we have fx equals x minus 5 to the power 4 and x minus 2 to the power 2. Okay, this factor of 5 has a multiplicity of 4 because of the exponent 4, and this factor of 2 has a multiplicity of 2 because of the exponent 2. Okay, let's make a star here. If a graph cuts through the x-axis, cuts through. At the root, so remember root is same as x-intercept. It has an odd multiplicity. Conversely, if a graph touches the x-axis at the root, and turns back, it has an even multiplicity. Okay, we looked at that in the characteristics note. If it has a multiplicity of 4, remember it's just a little flatter at the root than it would be as 2. Okay, use the characteristics of the polynomial function below to find its equation. So let's mark off what we know. So we have an x-intercept here, at -1, +2, +4. Okay, we have a y-intercept, let's call it around -8. So -8. The arrows are facing the same way, so that tells us it's an even degree. And they're down. Okay. The arrows are going down, which means it's a negative leading coefficient. Okay, and all that would come into play when we find the equation algebraically, but it's good to understand what all of this means. Okay, so let's look at how many turning points we have. It's another characteristic that we went through. And it turns here, here, and here, so it has 3 turning points. Okay, and x-intercepts, it has 3. Okay, and they are at -1, 0, 2, 0, and 4, 0. Okay, the degree has to be even, and even though there aren't 4 x-intercepts, there are 3 turning points, so it means that the degree is a minimum of 4. Okay, could be 6, could be 8, could be 10, could be any even number greater than 4. But remember, the turning points can be 1 less than the degree number. Okay, we have a y-intercept. We figured as -8. All right, so let's find the equation. Using all that information, really all we need is the 3 x-intercepts and the point that it gives us of 1, -12. Okay, so the equation algebraically, just because we don't know the a value, that's why we're doing this. It's fx equals a bracket, so we have x plus 1, x minus 2, and x minus 4. Now we look at our x-intercepts, we see that at -1 it touches and turns, and it does so without getting so flat, so we're going to say that at x plus 1 it is squared. The other 2 go straight through, so they will just have a multiplicity of 1. Okay, and then we're going to add the point that we know, and we know that there's a point on this graph of 1, -12, so the y is represented by -12, and each x is represented by 1. I'm going to do this completely step by step. Some of you might not need to, but it's still a good refresher. Okay, so we have 4 times negative 1 times negative 3a. When you multiply 4 times negative 1 times negative 3, we get 12. 12 times a is 12a. We'll divide both sides by 12. So a equals negative 1. Okay, so therefore, our equation is, you don't have to write the 1, but negative x plus 1 squared x minus 2 x minus 4. Okay, just because the equation at the start of this note was in standard form doesn't mean that we have to then expand this out into standard form. You can for extra practice, but it just asks for an equation, and factored form is an acceptable equation. So this